We are now going to take an aside here and talk about a topic which is not really that important for beginners, but I think will be useful for you to know so that you can understand more about the Haskell type system. And that topic is kinds. Suppose we have a function called int_div. We've already seen this function before and I'm going to reuse it here as an example. We define our type signature for the function as int_div takes two ints and returns an either string int. When we ask GHCi for the type of the function, it responds with the exact same type, which is what you would expect. Now what happens when we ask GHCi for the type of a type? If we ask GHCi for the type of an int, we get an error saying the data constructor is not in scope. And if we ask GHCi for the type of either string int, it responds again with an error saying the either string and int data constructors are not in scope. It also tries to recommend an alternative in case you meant to use a variable with a similar name, either, that already has an existing binding. In our case, the recommendation is not useful. But why does this occur? If we look at what the GHCi help docs say, we can see that $t, which is actually just short for $type, takes an expression and shows the type of that expression. Remember, expressions are formed by using the data constructors, and that is why we get these data constructors not in scope errors, because Haskell cannot find a data constructor by the name of int or either or string. That is because those are not data constructors, but type constructors. But conceptually, just like how we can ask for the type of a data constructor, we should be able to ask for the type of a type constructor. Is there such a thing as the type of a type? That is where kinds come in. You can think of a kind as the type of a type. And just like there is a GHCi command for asking for the type of an expression, there is also a GHCi command for asking for the kind of a type. We can use the :kind command and pass a type to do this. Alternatively, we can use :k for short, as we will see. The response returned by GHCi when we ask it for a kind of a type can be confusing. Let's ask GHCi for the kind of an int. And we get told that the kind of an int is a star. What exactly is this star? Well, a star represents a concrete type. That is a type which is fully formed. In other words, it does not have any type parameters. Similarly, for a string, the kind is a star. Again, because a string does not have any type parameters. Now let's look at the kind for the maybe type. But before we do that, let's remind ourselves of the type definition. Unlike an int or a string, the maybe type has a type parameter a, and so you would expect its kind to be slightly different. When we look at the kind of the maybe type, things get interesting. We now have a kind of star to star. What does this mean? Remember, a star means a concrete type, a type which does not take a parameter. So the maybe kind takes a concrete type and returns a concrete type. The concrete type returned will be the maybe itself. The star syntax may seem weird at first, but once it's been explained, it should make sense, like for the maybe case. Finally, let's look at the either type. As a reminder, here is the definition of the either type. It takes two type parameters, which it calls a and b. Can you guess what the kind of the either type is? Well, since it takes two type parameters, its kind is star, arrow star, arrow star. The first star represents the a type parameter, the second star represents the b type parameter, and the final star represents the concrete type which is returned. This look into kinds is a detour and slightly beyond what a beginner needs to know, but I thought we should definitely cover it, so, like I said before, you can get a better understanding of the Haskell type system. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.